Assalamualaikum. My name is Luqman Al-Hakim. My project title is Multi-Scale Interaction in Mixed Reality Remote Calibration. The problem background have three, which are when there's a delay in the routine application, occlusion will not work properly. This problem also causes the interaction to become weak. The second problem is head mount display, or HMD, become more complex with the advancement of technology, which require specialized knowledge to use. Broad et al. Also said that remote collaboration requires lower latency, but there's still no optimal network protocol and 5G network currently. This may affect the real time in mixed reality when the network is slow. For the problem statement, marker-based and markerless tracking is still have problem if marker for marker-based tracking got occluded by other object, the tracking will not work, while markerless cause problem when the surface is reflective or not many pattern for reference point. Also, remote collaboration cannot maintain awareness as the co-located collaboration because user is not in the same location. For the third problem, using a wrong virtual avatar size can affect how we perceive virtual environment. Multi-scale is important in sector that require precise measurements such as architecture or automotive industry. Too big avatar will perceive object as small, and if the avatar is too small, it will perceive the object as big. For the project objective, this project have three objectives, which is to study mixed MR remote collaboration and existing multi-scale interaction, to develop a multi-scale interaction between VR and AR user for MR, and to evaluate user experience with multi-scale MR application. For the literature view, mixed reality or MR is a combination of real and virtual world. MR also aware of its surrounding environment, while augmented reality or AR is a technology that able to overlay virtual object into the real world. For the virtual reality or VR, is a technology that provides full immersive experience, which allow user to enter virtual environment. Next, for tracking, marker-based and markerless tracking still have problem as stated in the problem statement. The tracking technique can be enhanced by using extended tracking by Vuforia. Extended tracking is like combination of both tracking. It uses marker and environment around the marker for the reference point. Extended tracking should solve the problem stated in the problem statement. Here show a table comparison between tracking. It shows that extended tracking is much more suitable for this project. Move on for MR collaborative interface. Using VR is a good if collaborator want to view the virtual environment like inside virtual house, while AR is good for face-to-face collaboration like discussing exterior design of outside of the virtual house. Using MR, the possibility of achieving both situation is higher. MR also can maintain awareness in remote collaboration, which can be solved the problem stated in the problem statement. In a collaborative interface, user need to complete tasks together. In remote collaboration, multi-user interaction in mixed reality environment need to affect one another. For example, if AR user move virtual object inside the MR environment, other user should also see the virtual object is moving. It should see the changes. Remote collaboration require networking. Photon Unity Networking or PUN is a plugin for Unity 3D game engine, which also support cross-platform. PUN is suitable for this project because AR user will be run in both Windows and Android, while AR user only run in Windows. For a multi-scale interaction, it is critical to align precisely the way we perceive the virtual world with the way we perceive the real world. Because PSM et al. Past research is very close to the project aims. The multi-scale technique used in his research will be used to guide in developing the project multi-scale interaction. The third method they use is smooth transition between scaling the virtual avatar without breaking the continuity to offer user the sense of relative to the surrounding. Using AR avatar as a placeholder to determine VR user avatar measurement and to trigger the triggering the multi-scale through controller. For Chapter 3 Methodology, MR collaboration between AR and VR. A standard marker base will be used for anchoring virtual environment. A standard marker base data will be generated from Vuforia website and import into Unity 3D with the Vuforia SDK. The marker will be used in AR environment and VR environment will be anchored to the marker to produce MR environment. The connection for remote collaboration to connect both users will be using PAN. For the scale ratio of virtual object, PSM et al. Use fixed avatar for AR user to determine the VR user avatar size, but in this project we will use different method. Now, physical object like table from AR environment will be measured and similar size of virtual table will be modeled and placed at VR environment. The both table will be used as a measurement tool to determine the scale ratio for the both AR and VR avatar. In the beginning of the application, before user can enter their own environment, both users are required to enter their real height into the application. Using the table measurement, the scale ratio for AR and VR can be found. For the multi-scale avatar, after obtaining the scale ratio from the previous, VR user can use the ratio for the multi-scale interaction, considering the smooth translation between three bigger or smaller stated by PSM et al. Lip scaling function will be used to offer user the sense relative to the surrounding. Lip scaling function is a function from Unity 3D engine. Oculus Touch will be used for toggling between bigger and smaller for VR user. Unity 3D will be used to construct the VR scene, and Unity 3D also include with object hierarchical. Object hierarchical will be used to attach the camera same height level with the VR avatar eye. In this way, if the avatar scale down or up, the camera size will follow. For the Chapter 4 expected result, here show the expected workspace for AR user. The AR user will use the physical book as a marker and use the VR and AR box as a HMD with the smartphone for Android and mic for communicating with the VR user. The Kinect sensor is used for detecting the 6 degrees of freedom, and computer monitor is used to capture what the AR is seeing and for existing or assessing the application, window application. For the expected workspace for VR user will use Oculus Rift and Oculus Touch controller. The Oculus sensor and Oculus Touch controller can give the VR user the 6 degrees of freedom. So when the user move, the avatar will follow. Similar concept for the computer monitor will display what VR user is seeing, and for assessing or exiting the application. So when the two user have connected, it show the MR environment. In the middle show the 3D virtual house and physical book. The physical book as a marker and the virtual house will be shown. Also, it show that the physical and virtual table is overlapping. So when the AR or VR user move, they will not collide with the table. This is the example showing that AR user have a different height and the VR user have a different height. This is the expected interface for VR setting So when to access the application, this is the window application. When the VR user want to access the application, they have to enter the actual height, and after entering the actual height, they have to click the find room to search for AR user room, and click start to start the application. Here show the application side by side for AR user and VR user. The difference is the button here, the button VR and AR. Actually, the application is the same, but the button will toggle based on which one user want to enter, either in VR or in AR. So in AR, the AR user can create a room, and while the VR user will need to find a room that AR user has created. He showed an example how the room will need to create. When clicking the creating room, a tab pop-up will show asking for room name, and click create to create the room. So when the VR user click the find room, it should list many room. So which one they want to connect. So when they connect it, they can start the application. This is an example how this display camera fit with exit button at the corner. This one is in the computer monitor. So when they want to stop the application, they can just click the exit button. Here how AR views perspective looking at the VR avatar. So this is the normal size of the VR avatar. And this is how when the user is teleport on top of the table and change the size into small size, so they can enter the virtual house in the middle on top of the book. Okay, that's all for me. Thank you.